Second part to this section 5.5 now is using u substitution with definite integrals. Okay, so now before we were just doing indefinite integrals, which really was just finding the antiderivative. Now what if we want to do it from 0 to 4? Actually find the area under the curve. So now we'll actually get a number for our answer. Okay, there's just one added step really. You're going to do the same thing. You're going to let u be the inside. Okay, you're going to change everything in terms of u. And the biggest difference is your limits are going to have to change. So from 0 to 4, we're going to have to change those in terms of u. I'll show you what I mean. Okay, so here it states the same thing, guys. The inside part's going to be u. So the integral is going to turn into f of u. Okay, as long as the derivative of the inside part also appears. And now the a and the b are going to change to g of a and g of b, which I'll show you what we're talking about there. Okay, so number 8, the first one. Let u be the inside part, which would be what? 2x plus 1. Okay, derivative of u in terms of x is just what? 2. Come up here, figure out this is your u. What's left is just dx. So solve this for dx. So you'd have dx equals 1/2 du. Okay, comes your integral. This would turn into square root of u times 1/2 du. Now, instead of going from 0 to 4, because 0 and 4 are in terms of x, I want to change these so they're in terms of u. So you're going to plug 0 in here and say when x is 0, what's u? So you're plugging 0 here. 2 times 0 is 0 plus 1 is 1. So the 0 becomes 1. Now we're in terms of u. 4. When x is 4, what's u? U would be 9. So these are now different because they are in terms of u. Okay, now what? You're going to do the same thing. You're going to bring the 1/2 in front. I'm going to write this as 1/2. And now it just becomes a definite integral that we've just did. Okay, so you have the 1/2 in front. So I'm just going to leave it there. Times what's the antiderivative of u to the 1/2 would be what? 2/3 u to the 3/2. I don't need the plus c because I'm going from 1 to 9. So now I go from 1 to 9. I don't need to plug 2x plus 1 back in for u. How come? Because I've changed these now in terms of u. So now I can just do this out with the u. That's the difference from indefinite to definite. You know, your last step before was to plug x back in here. I don't have to because I'm actually going to plug the numbers in to see what I get here. So now I'm not going to do this out. Plug in 9, plug in 1, subtract, and you can actually get your value. You can, just for algebra, so 1/2 times 2/3 is 1/3. You can leave that in front and then just do 1/9. So you could leave the 1/3 in front and plug in 9 to the 3/2 minus 1 to the 3/2. Any constant like that you can leave in front. You don't have to carry it with each part. You should get 26/3. Okay? Okay, let's just do a couple others. So number 9. Inside part, u is going to be 3 minus 5x. Okay, so the inside part. du in terms of x, derivative of that is just -5. Okay, now look, all I have left is the dx. Solve this for dx. So -1/5 du equals dx. Okay, so now go ahead and change it. So I'd have what? I'd have 1 over u squared. Okay, 1 over u squared times -1/5 du. Remember this, don't let this confuse you. It's the same thing as 1 over 3 minus 5x squared times dx. Anytime dx is in the numerator like that, it's like 1 over times dx. Okay. Now now what should your limits be? Okay, don't go from 1 to 2 anymore. When x is 1, what's u? So plug in 1 and you get -2. And when x is 2, what's u? So 3 minus 10 would be -7. So again, I'm boxing these just to remind you they change in terms of u. Okay, simplify, bring that -1/5 in front. -2 to -7 of u to the -2 powered du. Integrate. What's the integral of that? So add 1 would be negative u to the negative 1 from negative 2 to negative 7. And answer is 1/14. Once you get here, this is just from before. Plug in negative 7, plug in negative 2, subtract the 2, multiply by the negative 1/5. Okay? All right. Next one's a little tricky. Because you might say, well, what's u? There's no real inside part, so you got to think about this. What is the derivative of natural log of x is 1 over x. So you're going to actually let u be the natural log of x. Here, there's your u. Du dx is 1 over x. And look, you have 1 over x here. So again, this integral is the same thing as the natural log of x times 1 over x dx. Really. Okay, so solve this for 1 over x dx. So du would be 1 over x dx. Now just go ahead, substitute. So I'd have the integral of u du. This is du. Natural log of x is u. Make sure you change your limits. So plug in 1. Natural log of 1 is 0. Plug in e. Natural log of e is 1. So these change based on u. Go ahead. So the antiderivative of u is u squared over 2 from 0 to 1, and we get 1/2. Okay, so hoping you're getting the idea. It's not much different. You're just getting in your actual area under the curve. Okay, and the last one, a lot going on in the last one. Lots of sines and cosines. So the innermost function, if you look here, is sine of x. So I'm going to let u be sine of x. See what happens with this. So I would have the derivative of that in terms of x. Derivative of sine is cosine of x. So this is going to be u. And then what do you have left? You have cosine of x times dx. Okay, so now if I solve this, I would have du equals cosine of x dx. So that's taken care of. So this would turn into the integral of sine of u, because this is u. So I'd have sine of u times the cosine of x dx becomes du. That's it. So it's sine of u du. And then your limits change. Plug 0 in. Sine of 0 is 0. Plug pi over 2 in. Sine of pi over 2 is 1. So these are now in terms of u. Find the antiderivative of sine is negative cosine. And I'm going from what? 0 to 1. Plug those in, and you get 1 minus cosine of 1. If I leave it exact, because that's a decimal. So I'll just leave it like that. Or negative cosine of 1 plus 1. Okay? All right. The last part to this, I have symmetry. This is just, I've already actually said this in class. Okay? If you have, whoops. If you have x squared is even. I know we all remember that. X squared is an even function because it's symmetric over the y-axis. If you want to find the area, say from negative 1 to 1 under the curve, well, the area from negative 1 to 1 of x squared is actually equal to what? 2 times the area from 0 to 1 of x squared. So if you wanted to, if you realized you had an even function, you could just go from 0 and then double it because it's symmetric. And an odd function, if I go from negative a to a, I'm going to get 0. I've already talked about this. Think about x cubed. So if I'm symmetric over the origin, half is going to be above the x-axis, half is going to be below. They're going to cancel each other out. As long as you're going, say, from negative 3 to 3 or negative 2 to 2, then my answer is going to be 0 if the function is odd. Should make sense.